Okay, having known the quantum numbers now, it will enable us to write the electronic orbitals of an atom. That is one of the significance of quantum numbers. But before we do that, you should be able to know the three principles that will help you in writing electronic orbitals. The first is Albert principle. The second principle is Pauli exclusion principle. And the third one is Hund's rule or principle, the Hund's rule. With knowledge of your quantum numbers and this principle, you can be able to write or understand the electronic orbitals of an atom. Albert principle is also known as M plus L rule, which explains the energy levels of an atom. The Albert principle states that electron fills the lower energy levels. In field of electrons, the lower energy levels are filled first. Electrons fills orbitals with lower energy level before orbitals of higher energy level in the order of filling electrons in an atom. Remember, an atom can gain electrons, it can lose electrons. So in the filling of electrons, Albert principle states that in filling of electrons, fillings of electrons in an orbitals with lower energy levels are filled first before orbitals of higher energy level. What it implies that, how do you know orbitals of higher and the lower energy levels is the use of M plus L rules. For example, I have 1s, 2s, 2p, 3s, 3p, 3d, 4s. Who will fill first? The one of the lowest energy level is going to fill first. Now, let's start filling of the first energy levels of an atom, which is first energy level. How many electrons can occupy the first energy levels of an atom? Do you remember again? How many electrons can occupy the first energy levels? 2 electrons. Remember? 2n squared. 2, 1 squared, which is 2. So only 2 electrons can occupy the first energy level. So in the first energy level, how many orbitals can you have in the first energy levels? That is possible to have in first energy levels. You're supposed to have up to 4 orbitals. Remember, I taught you S, P, D, F, right? So you're supposed to have 1 S orbital. That is first energy level with in the S orbitals of the first energy level. 1 P orbital of the first energy level. 1 D orbitals of the first energy level. 1 F orbitals of the first energy level. Is that not so? Pay attention. But the number of electrons that can occupy the energy levels, first energy level is 2. Which of these place will it occupy? Albert principle says the one with the least energy level. Now, if I have 1s is the least energy level here because n plus L rule means n is the n value, which is the principal number plus what is S value? S value is 0. Remember the values we attach to each of them. S is 0, P is 1, D is 2, and F is 3. So that is M plus S, 0 is 1. So the energy level, the value of the energy is 1. M plus L value determines the energy levels. The one of lower M plus L value is the one that have the lower energy level. So here it will be 1 plus P, which is 1, which is going to give you 2. The one with the lowest energy level is 1s. 1s has lower energy than 2s. 2s will be 2 plus, what is S value? 0. 2 plus 0, which is 2. So it has higher energy level because it has higher M plus L value. Look, if I have 3P, if I have 3D and 4S, who is going to fill first? According to our principle, the one of lower N plus L value. That is lower energy level. 3 plus what? D, what is the value of D? D is 2. 3 plus 2 is what? 3 plus 2 is what? 5. Here is 4 plus S. What is S? S is 0, is it not? So 4 plus 0 is what? 4. So have you seen the reason why 4S fails before 3D? Because 4S have lower energy level. That's why when I have 1S, 2S, 2P, 3S, 3P, because 3P has higher energy level than 3D. 3 plus, look at the values here. Here is 1S. 1S is 1. 2S is 2 plus 0 is 2. That is the value of the M values. Here is 2 plus P. P is what? P is 1. 2 plus 1 is 3. Here 3 plus 0, 3 plus s, 0 is 3. Here 3 plus p is what? That is 3 plus 1 is 4. Then after 3p is supposed to be 3d, but 4s has lower energy first. 4s is still 4. Are you there? Before 3d, which is 5. So they fill based on the m plus l value. There is condition attached to that. When the m plus l values are the same, the one with lower n value fills first. The one with lower n value fills first. Here, the n plus l value is not the same. It's 5 and 4. So 4s fills first before 3d. While filling. That's why you have 4s filled before 3d. But here you have 3p and 4s. What is n plus l value here? N is 3. What is p? 1. 3 plus 1 is 4. Here, 4 plus s is 0 is 4. They have the same n plus l value. The one of lower n value, n plus l value, is the one with lower energy level. That one will fill first. But in this condition, they have the same n plus l value. What I'm going to do? When they have the same n plus l value, the one of lower n value is going to fill first. Who is going to fill first here? 3p before 4s. 3p is going to fill first before 4s. Why? Because 3 is less than 4. N value here is 3, while the n value here is 4. The one with lower n value, this n value, the principal quantity number is 3, is going to fill first. If I have 6x and 5d, who is going to fill first? According to the above principle, which one have lower energy level? These orbitals, which one have lower energy level? You use the n plus l value. Who has lower n plus l value here? 6 plus s is 0, is 6. Here is 5 plus d is what? D is 2. 5 plus 2 is what? 7. So in filling of your orbitals, 5d, 6s is going to fill before 5 because 6s has lower n plus l value than 5d. So this is what our principle explains, that electrons are filled based on the energy levels. The ones of the lower energy levels are filled first. How do you know the energy values? N plus L value. When the N plus L values are the same, the one of lower N value fills first. The one of lower N value fills first. Do you understand? So this forms the order of filling electrons. Now, in the first orbitals of an atom, in the first energy level of an atom, we have 1s. So how many electrons can occupy s orbitals? Do you remember how many electrons that can occupy s orbitals? 2. Thank you. 2 electrons. Why? It has only one m value. The magnetic quantum number is 1. It's spherically safe. It can only occupy 2 electrons because it has only one magnetic quantum number. It's important to see that if 2 occupies here, what it means is that the first energy level can only also have a K shell, can only have maximum of 2 electrons. The 2 electrons that occupy the first energy level has occupied the s orbital. So 1p, 1d, or 1f are mechanically forbidden. It's no longer possible because there's no electron that's going to fill them. First energy level is already completely filled because K shell can only have 2 electrons, and these 2 electrons has been taken by the s orbital. So nothing is going to fill 1p, 1d, and 1f. If I go to the second energy level has a maximum of how many electrons? 2n squared, remember? Which is 2 squared, right? Which is 2 times 4, which is 8 electrons, right? So if the second energy level is going to have 8 electrons, I have 2s will fill first before 2p, before 2d, before 2f, right? But it's only 8 electrons that can occupy the second energy levels. 2s, remember 1 plus 0 is 1, is going to fill first before this. If 2s fails, how many electrons can occupy the s orbitals? 2 electrons can occupy s orbitals, is it not? How many electrons can occupy p orbitals? The maximum number of electrons that can occupy p orbitals is 6 electrons. Why? Because p orbitals have how many suborbitals? 3 suborbitals, px, py, pz, is it not? Each of them can occupy a maximum of 2 electrons, is it not? That is 6. 2 plus 6 is what? 8. How many electrons can occupy the second energy level? 8 electrons. So These 8 electrons has been taken by the s orbitals and p orbital. So 2d does not exist, therefore 2f does not exist. So they are mechanically forbidden in orbitals. They are mechanically forbidden. There is no electron that can fill 2d orbitals or 2f orbitals because the second energy levels are complete at 2p. Does that make sense to you? If we go to third energy level, remember how many electrons can occupy the third energy level? 2n square again, 2 3 square, right? 2 times 9, 18 electrons. So if 3s is filled with 2 electrons, afterwards the next one, 3p, maximum electron is going to be 10. Do you remember? That is 5. M value is 2l plus 1, which is 2l is 2 now plus 1, which is 5. Do you remember? So it has maximum of 10 electrons. How many electrons will third energy level have? 18. Is it not? Sorry, here is 6 electrons, so not 2 electrons. So 10 plus 6 is 16, right? Plus 2 here is 18. So 3 orbitals, energy level, third energy level can fill up to 3d, but 3f is forbidden because at 3d, the 18 electrons has been completely filled. So 3f is forbidden. No electron can fill 3f orbitals of the third energy level, the f orbitals of the third energy level. It goes like that. If I go to 4s, what will I have? It will be the same. K shell, L shell, M shell, N shell. We have the maximum of, that is the fourth one, 2n square, which is 2 4 square, 16 32. So 4s, this 32, right? 4s2, 4p6, right? 4d what? 4d what? 4d10, 4f what? So 4f can fill. That is at 4 energy level, f orbitals can be filled. At fourth energy level, f orbitals can be filled. At third energy level, you cannot fill f orbitals. At second energy level, d orbitals and f orbitals cannot fill. At first energy level, p orbitals, d orbitals, and f orbitals cannot. So you can see that the 1 orbitals are added at each of the energy level. First orbital is here. How many orbitals are filled here? 1 at the first energy level. Second energy levels fills only 2 orbitals, s orbitals, and these. Third energy level, s, p, d are filled. And the fourth energy levels, all the 4 orbitals are filled at the fourth energy level. So take note of that. It helps in writing electronic orbitals of an atom. If I have 5 orbitals, if I have the fifth energy level now, fifth energy level will also be filled up by the all of them, is it not? Yes. So this gives us the, we will now say if you have 1s, after 1s is 2s, 2p, 3s, 3p, and 3d. You don't have anything like 3f, is it not? 4s, 4p, 4d, you now have 4f, is it not? If I have 5s, I will still have 5p, 5d, I will still have 5f, is it not? This becomes the order of filling. 3p fills first before 4s, is it not? But 4s fills first before 3d. After 3d is filled, 4p is filled, 5s. Imagine that 5s will fill before 3d. Why? 5s fills before 4d. 5 plus 0 is 5. 4 plus d is 2 is 6. So 5s fills first before 4d. And the 5p fills first before 4f, as you have seen. 5p fills first before 4f. Look at the reason. 5p fills first before 4f. 5p is 5 plus 1, which is 6. 4f is 4 plus 3, is it not? Which is 7. So 5p fills first before 4f. This is called Auber principle. Auber principle. Auber principle. The next principle to take note of is Hund's rule. The next principle to take note of is Hund's rule. Okay, is Pauli exclusion principle first. Pauli exclusion principle. Pauli exclusion principle. It states that when filling electrons in an orbitals of an atom, electrons are filled singly in a disarranged orbitals before pairing. in a degenerate orbital or the suborbitals. You don't call it degenerate orbitals, you call it suborbitals. The degenerate orbitals of an atom, electrons are filled singly before pairing. Electrons are filled singly before pairing. What does that mean? If I have, for example, carbon, what is the atomic number of carbon? 6, right? Atomic number of carbon is 6. If I want to fill, it's going to be like this: 1s2, 2s2, 1s2, because s can only have 2 electrons. 2s2, 2 can only have 2 electrons. Is it complete? No. I move over to the next 2p. How many is remaining to make it 6? Remain only 2. I'll put the 2 here. To elaborate this more, 1s means it has one suborbitals, and this 2s is going to fill up. 2s means it has only one suborbitals and 2 is going to fill up. When you come to 2p, it does not have only one suborbitals, it has degenerate orbitals or suborbitals of 3. 2px, 2py, 2pz. This is where the law holds that in filling of this place, the electrons have to fill singly before pairing. These 2 electrons here is not in x orbital. They fill singly. If it is filled up before it will pair. After carbon, what's the next one? Next one is nitrogen. If nitrogen should enter, it becomes 1s, 2 will fill up, 2s, 2 filled up first. Then you go to 2p. You have the degenerate orbitals of 2ps, 2py, 2pz. So in this condition, it still fills singly 1, 1, 1. You cannot say the 3, 2 will be here, 1 will be here. It's wrong. They will first fill singly before pairing. That is the Hund's rule. In oxygen now, what are you going to have? You're going to have again 1s, 2s, they will fill, but when you come to degenerate orbitals, they begin to fill singly before pairing. 2ps, 2py, 2pz. The same thing will happen in 3p, the same thing will happen in 3d, and so on and so forth. Here, you fill 1, 2, 3. It's filled up. Is it up to 8 now? 1, 2, 3, 4, 5, 6, 7. Remaining 1. Then the first one will now pair. That is the order of filling electron. If I want to fill the fluorine now, fluorine is 9. It becomes 2 here, 2 here, 2 here. Here is filling singly now. Is it not? 2ps, 2py, 2pz. It fills singly and start pairing. What is remaining to be paired? 1 will be here, 1 will be here. It's now up to 9 electrons because the number of electrons is equal to the atomic number as far the charge, the atom is not charged. Remember, I've told you that earlier. As far the atom is not charged. If atom is charged by 2, it means it has gained, if it's for this is charged, positively charged by 2, that means proton is now more than an electron. It has lost 2 electrons. If it's charged by -2, that means it has gained 2 electrons. It's going to be not 6 again. This one becomes, electron here becomes 8. It has gained 2 electrons. Here, electron here becomes 4. It means it has lost 2 electrons. Is it not? Yes. It means it has lost 2 electrons because proton now is more than an electron by 2. But when it is not charged, the number of protons, which is atomic number, is equal to the number of electrons. I've explained that in our last class. So you can, I believe you can fill the first 30 elements, more than the first 20 elements now, and you can fill them accurately. Do that and drop your answers in the section in the assignment. Submit the assignment at the assignment section of the class. I'm going to state it there. If I'm starting with hydrogen, now hydrogen is going to be first. Hydrogen is 1s1, is it not? That is, I don't want to put this here, it will be here, 1s1, because there's only one. Helium is 1s2. You can still put it in this way. After helium is lithium, it's going to be 1s2. How many is remaining to make it up to 3? 1 electron is going to be, after 1s2, 2s1, 1 will be here. I will not put 2 here because I will not put more than the electron we have. 3, atomic number of 3 means it also have 3 electrons since it's not charged. So if 2 has occupied here, what is remaining is 1. Do you understand? If I have after the lithium, what's the next one? The beryllium is 4. If 2 electrons occupy this one, how many is remaining? 2 electrons is going to occupy the next one. If I have boron, which is 5, 1s2, 2 occupies here, what is going to occupy here? 2 electrons will only occupy s orbital. After that, what is remaining to make it 5? 1. Then you go to the next orbital, which is 2p. It's going to be 1. It's going to be 1. After that, you have the carbon. If I want to put this in more elaborate form, electronic orbital configuration is going to be 1s, the 2 will be here,